So we're back to this setup where we have a table and we'll do the graph. I laid out degree measures, again, only till 300, bad planning. But we know there are repeating patterns to the values, so we'll be able to see exactly what we need with the table that we've got. Okay, we're thinking slope. So our first point is at a rotation of 0 degrees, and the slope of a line from the origin to that point, it's horizontal, so its slope is 0. Okay, next we're increasing our slope. So we're at radical 3 over 3, equal to approximately 0.58. Then slope of 1, then the slope of radical 3, and now our slope is undefined. Let's not put a number there. Now into quadrant 2, and remember, at this point here, I'm on a downhill line. It's the same value for tangent that I would get at this point down here, but I'm thinking a line from this point to the origin. It's downhill, so it's got a negative slope, and it's a pretty steep one. I know that this steep line was the radical 3, so this downhill steep has to be a negative radical 3, approximately negative 1.73. So we'll continue. Now we're downhill at negative 1, downhill with slope not so steep, negative radical 3 over 3, and now we're back to a slope of 0. Once we rotate into quadrant 3, we're back to uphill lines, a positive radical 3 over 3, then positive 1, positive radical 3, and now again at 270 down here we're same as at 90 degrees, a slope of a vertical line that's undefined. Now 300 we're back to a downhill, a very steep downhill, negative radical 3 over 3, and so on. Let's plot these points. Okay, 0, 0, so another function that does cross through the origin. Sine and tangent cross through the origin. Cosine did not cross through the origin, crossed up here at 0, 1. Let's plot these other points. Again, my increments are 15 degrees, so at 30 I'm going up to 0.58 approximately. 45 degrees I'm up to 1. 60 degrees way up to radical 3, about 1.73. Now what should we have at 90 degrees where a value is undefined? And I like your answer if your answer was asymptote. Vertical asymptote, wherever we have functions that are undefined for that value of theta. Tangent of 90 degrees, undefined. So at 90 degrees, a vertical asymptote because the graph does not exist there. And now we're moving on to our next point at 120 degrees. We shot from a way up here with a positive high slope. Now we're down to a very negative slope, way back down here. And now we're increasing up to negative 1, a negative radical 3 over 3, then slope of 0, now some positive slopes. And we're at 270 degrees now, another vertical asymptote. There's our value at 300 degrees, and we have a repeating pattern. I filled in the next ones here. I filled in a couple in the negative direction because tangent also can handle negative angle measures, and it can handle angle measures that are in excess of 360 degrees. That's why we get the repeating pattern. Let's connect all these, try to keep it smooth, more or less. Now, talking about period in this case, our repeating pattern did not require a full rotation around the circle, 360 degrees. It only took halfway around the circle. Here we had, in quadrant 1, positive slope. In quadrant 2, it shot down to negative slope. But once we got into quadrant 3, we matched up exactly with quadrant 1. We were repeating ourselves just after half of the circle. So period is only 180 degrees, and we could even count it. There's 30, 60, 90, 120, 150, 180 degrees, or pi radians. So it's important for us to know that the period for tangent function is only 180 degrees, or pi radians. For cosine and sine, it was 360 degrees, or 2 pi radians. So let's take a look at the computer-generated tangent graph, and there it is. The asymptotes are not put there for us. We could put those in just to really indicate where we have our period and where we have these values that are not allowed. One last thing I'd like to talk about quickly, I'm sure it will come up again, domain and range of these functions. Now with tangent function, domain, we're talking about as we move along the x-axis, are we seeing any breaks in the graph? And absolutely we are. Our domain is all real numbers except, let's see, this was 90, this was 270, this one would be 450. So we have all real numbers except starting with 90 and then other increments adding 180 degrees. A little bit of a complicated domain there, but definitely we've got values that are excluded from the domain. But how about range? Are we able to see values continuously all along as we move vertically? So yeah, we're getting very negative function values, we're getting zero function values, and we're getting positives. So range, all real numbers, but domain, not all real numbers. We've got some values to exclude here. And let's also talk about domain and range for sine and cosine. Here's our cosine function. First, domain. Are we seeing any breaks moving horizontally? No, it's totally continuous. We can define cosine for any angle measure. But what about range? What y values are we getting? We're only getting y values in between -1 and +1. So our range just from -1 to +1, including those endpoints, and domain, all real numbers. And the graph of the sine function is working in a very similar way. It's got the same shape, just shifted by 90 degrees. Its domain is all real numbers, and the range only between -1 and +1, including those endpoints.